Okay, so today we're learning more about slope. M equals y2 minus y1 over x2 minus x1. Now we also, that's the slope formula. We plug into that. Sometimes we just call this rise. That means vertical change over run, which is horizontal change. Or sometimes we call it change in y. That's delta y over delta x. It means change. That delta symbol means change. So let's find the slope. Using the slope formula, so we're going to plug in to this guy. So you take your y values first. 4 minus 2 over, go in the same order, negative 3 minus 3. And you get 2 over negative 6. And if we simplify that, we get negative 1/3. And so that's our slope. There's another way of looking at slopes. We look at it graphically. If you do that, you get negative 3, 4. There's that point. And 3, comma 2. There's that point. And if you connect them, well, let me use a straight edge. That's not very good. Let's see. Okay. So using a straight edge. There we go. That's pretty good. So to find slope graphically, you want to find a couple of slope points. In this case, we have these two nice points we could use, or we could even use this point in here if we wanted to. So you rise up, like in this case, we went up 2. 2 is a positive direction for y. Y in the negative direction is down, up is positive. X is a positive direction to the right, X is a negative direction to the left. So if I go up 2, that's my rise. So I have 2 divided by my run up. I go to the left, 1, 2, 3, 4, 5, 6 units. So I put like a negative 6 up there because I went in a negative direction. So 2 divided by negative 6. And we end up getting the same thing of slope of negative 1/3. It's a little harder to do this kind of question. You might want to try this, stop it and pause it and try it. To find the slope, you need to identify the nice slope points, like there's a nice point where the x and the crosshairs go through there. There's a nice integer point, there's a point, here's a point, and here's a point. It doesn't matter which 2 points you pick, although it's easiest to pick 2 that are closest together. So in this case, if I go up 2, it'd be a rise of 2 divided by a run of 3 in the negative direction, so negative 3. So we have a slope of negative 2/3 would be our slope. Finding the slope of an equation, of course, easiest way to do that is just to solve it for y probably. Well, it's maybe not the very fastest way, but it's pretty good. When I subtract 4x from each side here, I want you to notice a little nuance that I do. Instead of putting 5 minus 4x, I'm going to say equals negative 4x plus 5, because I really want to get into the form of y equals mx plus b, where b is my y-intercept and m is my slope. Then I would divide by 2. Another little thing I do here is I always divide each term by 2, not the whole side by 2. So I get y equals negative 2x plus 5x. So you have a slope of negative 2 there, and a y-intercept of 2.5. There is a shortcut. If you take the standard form equation and solve it for y, you get a slope of negative a over b. And that's actually the shortcut. It's a pretty quick way of solving it. So we could have, if we wanted to, look at this and say, okay, my a is 4, my b is 2, my c is 5 there. Coefficient of x, coefficient of y, and the constant on the other side. So if I just take negative a over b, that would be negative 4 over 2, which is negative 2. That's a lot faster, but you have to remember that formula, and sometimes students will forget it. But that is the slope. Given in standard form, you can find the slope very quickly doing it that way. This is stuff you probably remember. It's been a little while, but given a point and a slope, you should be able to write the equation. So one way of doing that is to take the slope-intercept form and plug stuff in. Now it should be somewhat obvious. where this goes. It's going to plug in there for m, so we're going to plug that in. You might even know where this goes, right? That's your x value of a point, and so it's going to get plugged in there for x. Here's your y value, and it's going to get plugged in there for y. And so really the only one we don't know here is b. So we plug in everything else we know. It's kind of a lot of plugging in. Equals 3/2 times -4 plus b. Let's simplify a little bit. We get -12/2, which is -6, plus b. Hopefully you can tell the difference between my 6 and my b here. And then add it, and you get 7 equals b. Now, the thing is, we're not done once you get that. Because really, when you have the equation y equals mx plus b, you're really looking to find two things. You have to find the slope and the y-intercept and plug them in. Well, we know the y-intercept, we know the slope, so we finally write our equation. This will be y equals 3/2 x plus 7. So it takes an extra step using this method. We can do this another way about the slope. This method is actually more popular as you get towards pre-calculus and calculus. It's a very good method. You might remember it's called the point slope form. Y minus y1 equals m times x minus x1. Now what's a little different is what you plug in here. So obviously the 3/2 is going to go in there for m. Here's what's different. The -4 will not go in there for x. It actually goes in there for x1. And then the 1 goes in there for y1. So we plug in for those three things. It's just a little different. But one thing that's nice about this method, once we plug it in, y minus 1 equals 3/2 times x minus -4, which is like boom, boom, plus 4. We now have our equation. That's their equation for the line. It's not in a nice form of slope-intercept form. If we wanted to put it in that form, we certainly could. Let's go ahead and do that just for fun. Y minus 1 equals 3/2 x. 3/2 times 4 is 12/2, which is 6. Add 1, we get y equals 3/2 x plus 7. By the way, if you wanted to, just show off to your friends. Remember we mentioned standard form a minute ago, ax plus by equals c. I'm not sure if it's in this lesson, but you need to know this if you don't already. In standard form, this number is always positive. So you have to make that sure that number is positive. And the other thing that's true is a, b, and c all have to be integers. So if we wanted to put this slope-intercept form into this form, right? You've got to just make sure some of these values are the same. So I'm going to get x on the other side. I'm going to subtract 3/2 x. So I have -3/2 x plus y equals 7. Notice we have a denominator of 2 here. I don't want that. So if I multiply everything by 2 on both sides of the equation, let's see what happens. We get -3x plus 2y equals 14. I'm almost there. Again, a needs to be positive, so you might want to multiply by -1 here. You get 3x minus 2y equals -14. And so that would be considered standard form for this equation. So there's three different forms we know. Standard form, slope-intercept form, which is y equals mx plus b, and point-slope form, which is this form right here. Parallel and perpendicular lines. You might remember some of this stuff here. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So you have to do two things to find the slope of perpendicular lines when they hit at 90 degrees. You have to flip it, that's reciprocal, and then change the sign here. So let's look what a problem might look like. So if I want perpendicular lines, that is perpendicular, I want a line that's perpendicular to the line y equals -1/2 x plus 3. So I want a line perpendicular to that goes through the point, let's say 3 comma 1. So if we have this question, really what we want to identify is from this equation we've got to find the original slope. It's negative 1/2. Let's go back and look at this. The original slope is negative 1/2. So the perpendicular slope, if that's the slope of the original line, will be equal to, I flip it, so I get negative 2 over 1, change the sign, I get positive 2. So my perpendicular slope is 2. I don't care about the y-intercept of the original line. I really just want to take the slope. That helps give me the perpendicular slope there. I do know it goes through this. So if you know it has a slope of 2 and it goes through this point, that's enough information for us to write the equation. So we could use a number of different methods. One would be the y equals mx plus b method, where we plug in y and x and m. So it would be 1 equals 2 times 3 plus b. And so that would be, let's subtract 6, we get negative 5 equals b. So my final equation would be y equals 2x minus 5. Sometimes it helps to visualize what that looks like. If we graphed our original line in blue, this line would have a y-intercept of 3, a slope of negative 1/2. That means down 1 over 2 to the right, or up 1 over 2 to the left. And I like to put a few more set points, so if I don't have a straight edge, it still looks alright. So that's that original line. And I want to go through a point here at 3 comma 1. That point is not on the line, and it has a slope of 2, so we go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Please see that line, something like that. And according to this, the slope should be 2. Yes, the y-intercept should be negative 5. It is. We just double check that we had it right. You don't have to double check it every time. I just want you to see graphically what we're doing. We don't care about the y-intercept of the original line because we want to have a different y-intercept in most cases. We want to have a slope of 2, which is the opposite reciprocal slope that goes through that point. So you'll have some questions like that. I think that's probably the toughest type of question you might have in the next quiz, which should be a lot easier than your last quiz. Hope you enjoyed this.